In this video, we're going to do for an infinite limit what we've already done for certain finite limits. Okay? And that's this. I've got a function, 1 over x squared. The limit as x approaches 0 of that function is infinity. Okay? So, infinity is not a number. I can't get close to it. I'm not going to have an epsilon. I'm not going to have a standard of closeness for this limit. I'm going to have an m. I'm going to have a standard of bigness. So I'm going to say my function value counts as big if it's above 1 million. Okay. And what we're asked to do is find a delta bigger than 0. So that's going to be a positive number that's a standard of closeness for our x values. Such that if this would be the absolute value of x minus 0, that's the distance between x and 0. Notice I could have just written that as the absolute value of x. I wrote in the minus 0 just to really emphasize that, hey, it's the distance between those two things. And I want that to be bigger than 0. X can't be 0. That's actually rather important here because 0 is not in the domain of my function. But I want it to be smaller than delta. So I want x to be close to 0 using delta as my standard of closeness. And if that's the case, I want my function value, 1 over x squared, to be bigger than 1 million. Now, I'm just going to draw myself a picture here. So I know what 1 over x squared looks like. And I'm going to draw in my m here at 1 million. So I can sort of see that there's a point on either side of 0 where my function crosses that line. And as long as I'm in between those 2 points, my y value is bigger than 1 million. So I want to just sort of follow those down. This is going to give me an x1. This would give me an x2. Let's see if we can't find those. It looks to me like the distance between x1 and 0 and the distance between x2 and 0 is going to be the same. Okay. Now I know I wasn't drawing things perfectly to scale, but I do know that this graph is symmetric about the y-axis, so that should be what happens. Let's just confirm that. Okay. If I go to solve x1, I can say, 1 over x1 squared. That's going to be the y value that I get when I plug in x1 to this function. But I know that's supposed to be 1 million. So, let's see. 1 is equal to 1 million times x1. Times x1 squared. Multiply to get that out of the denominator. Then I can divide by it. So x1 squared is going to be 1 over 1 millionth. Okay. And then I can take the square root of both sides. So I'm going to get 1 over 1,000. 1,000 has 3 zeros. If I square it, I'm going to double the number of zeros to get 6, which would give me 1 million. And that's going to give me the absolute value of x1. I do need to be very, very careful here. The square root of x1 squared is not x1. I can see that x1 needs to be a negative number. Square roots are going to give me positive numbers. Okay. But the absolute value of x1 is this. And then I know that x1 is negative, so I can say x1 has to be the negative number that has that absolute value. So it's negative 1/1000th. Now, if I do the same thing for x2, I'm going to get almost exactly the same thing. I'm going to go ahead and write it out, but all that's going to change is the sign of it. Because I know 1 over x2 squared has to equal 1 million. So, doing a little bit of algebra, 1 over 1 million is equal to x2 squared. I can take the square root of both sides. So I get 1 over 1,000 is the absolute value of x2. But just looking at my graph, x2 is positive. So x2 would be the positive number that has that absolute value. So that's positive 1 1,000. And then I can say, okay, well, the distance between 1 1,000th and 0 and the distance between negative 1 1,000th and 0, it is the same distance on both sides. My delta would be 1 over 1,000. Now, that's not a formal proof for two reasons. One, we did that for a particular value of m. We didn't do that for an arbitrary standard of bigness. Two, we just did the work of finding delta. We didn't do a formal write-up to prove that it works. For infinite limits, I might do something like this, where I give you the standard of bigness and I ask you to find the standard of closeness that you need. I would only ask for a formal proof for a finite limit of a linear function or a linear function with a whole limit. Okay, so you're responsible for knowing the definitions for all sorts of limits. You're responsible for, given a standard of bigness or closeness, being able to find the corresponding standard for x, for infinite limits as well. But for formal proofs, we'll restrict that to two-sided limits of linear functions or linear functions with a whole limit. Okay?